topic or my presentation called Optimizing your Late and Dry Hopping. And I would like to start with the late hopping first and move on to dry hopping afterwards. But first of all, wrong button. So I brought this map with me because today I'm representing two parts of our brand or company group, because I'm presenting for John Haas from the US and for Bart Haas from Germany or and in China, because yes, I'm co-responsible, or I'm part of Bart Haas. All the companies you can see on this map belongs to our group, and it's always or sometimes a bit confusing, but yeah, we belong together. Good, but yeah, just let's jump into the presentation. And as mentioned before, I would like to start with the whirlpool or late hopping, as you can say. And first of all, I would assume that most of you made the experience that if you dose too much hops in your whirlpool, your troop cone or the formation of your troop cone is just dispersed. And this will happen, or is can be traced back to the just amount of hops you're dosing. Because based on literature reference and experience from the brewery downstairs, the limit for a sufficient troop formation is about 500 grams per hectoliters of hops, hop pellets. And if you're dosing above this this limit, your troop will not formate that sufficient efficiency, and you cannot you will lose a lot of beer or wort in the troop, because you cannot drain all the wort out of the whirlpool. And I would say the worst case scenario, if you're overdosing your whirlpool with hops, is that some hop particles can block your heat exchanger, and this would say the worst case, because it will ruin the whole brewing by just one day, by just one thing. And there are some heat exchanger which are wider, and don't get blocked that soon, but I'm not sure how many of them exist and are installed at the moment worldwide. But to give you a bit of insight what I'm talking about, I brought these pictures with me from a presentation from a former colleague from John Haas, Michael Wiske. And yeah, as you can see, there are three different pictures. Let's give you some insights in the experimental setup. So they dose in different hop products according into the boiling kettle and into the whirlpool, and each product was dosed into or to achieve 10 IBUs at the beginning of boiling and 30 IBUs by dosing into the whirlpool. And after transferring the wort out of the whirlpool, they weighted the amount what's left in the brew kettle and the amount of beer in the fermenter, and based on these numbers, they calculated the losses. And the average losses for the three different products for the T90 pellets was about 11.4, for the T45s, for the enriched pellets 7.3%, and for the just use of CO2 extract in both editions, the losses was reduced to 4.3%. And this is what you can see, what you lose when you're adding or what you're using different hop products. But as you can see on the CO2 extract, as I mentioned before, it's only hopped with the CO2 extract. The true formation is not that efficient or sufficient, because there was no added hop particles or green material, and for formation of the troop, you need some hop pellets at least. So this would be my recommendation, that to reduce your whirlpool losses, you should use for bittering CO2 extract or flax, was the product for bittering from our colleagues John Haas, and in the best or for best efficiency, I would recommend to use enriched pellets like the T45 or Lupomax. And by using the combination of both products, you will achieve a higher output per volume because you can drain more wort out of your whirlpool. And by adding less green material, you just reducing the amount which is soaked into the spent material. So would be a good way to reduce your losses. And let's move on to the next one. And based off the topic, or I choose this slide because the topic of the Brew is stronger for the future. And I would like to talk about how to calculate your dosing for amounts of dosing for the whirlpool and make them more reliable or predictable for the future. And I would say the most common way of calculating your hop additions for the whirlpool is grams per hectoliters. And I would like to show you why it makes more sense to calculate your whirlpool additions according to milliliter per hectoliter. And I brought this table with me to make it more practical. And as you can see, there's just two numbers for two fictional citra hops. And in the first year, you got alpha acid content of 12.0, and the next year 30%. And for the first year, 2.5 milliliters per 100 gram, and the next year 2.8 milliliters. And if you're dosing according to grams per hectoliters in the same year, so let's say 300 grams per hectoliter, you're dosing in the first year 36 grams per hectoliter is alpha acids, and in the next year 39. And this will sum up to a change in your bittering profile of about 8%, which is not that much, but should be kept in mind. But if you're looking in the hop oil dosing, you're dosing 1 year 6.6 milliliter per hectoliter, and in the next year 8.4 milliliter per hectoliter, and this is just a 21% deviation from one to another year, and this can occur if you're dosing according to 2 grams per hectoliter, because citra from time to time can vary from 1 up to 4 milliliters per hectoliters, and I would recommend you to dose according to milliliters per hectoliters because it makes more sense because you're adding for the flavor and not for the bitterness, and the flavor is in the oil and not in the alpha acid. So this is the which I would recommend to dose according to milliliter per hectoliter, and it's just based that hops are just a biological product, and it's under the annual fluctuations of what's going on. So based on the soil condition and all this stuff, and what's going more challenging for the future is the climate change or crisis. What's going on is makes more difficult to or makes a huge variation in the hop production. So, and on the next slide, I would like to show you why it's important, or why you should always use whirlpool additions for always achieving a higher amount of flavor output of your beer for dry hopping. And these are just a spider web based on some internal research we did in the past years. And as you can see, when you're only dosing pellets in the whirlpool or exclusively in the whirlpool, you will not achieve that much bold flavor by compared to as if you dosing into the whirlpool and in dry hopping. So this shows very good how to increase the flavor output just by using a combination of whirlpool and dry hopping. But yeah, this is also far for the latent dry hopping, which I like to talk about, and I'll move on to the dry hopping. Of course, we're talking about these two stages and the dosing into fermenting or storage tank. And the one of the biggest questions regarding dry hopping is more even always more? Like, if you're dosing more hops into your storage or fermentation tank, will this result in more higher flavor output? And the answer is unfortunately quick and simple. It's not. So this graph came from a publication from Thomas Schallhammer and Scott LaFontaine, which did, from my point of view, awesome research in the field of dry hopping in the past years. And as you can see, there are three curves or lines, and the black one is the overall hop intensity aroma, and the gray one, the lower one, is the flavor output in regarding the herbal and tea flavors, and the lowest one is with the white circled is the citrusy. And as you can see, by just increasing the dry hopping rates to, let's say, 16 grams per liter or 160 grams per hectoliters, you result in kind of increasing your overall hop aroma. But as you can see, the lowest one, I would say, this is the one what we are all looking for when you're dry hopping, because for the citrusy flavor, and this doesn't make that much sense to overdose your hops, because you don't yield in more aroma just by adding more and more hops to your storage or fermentation vessel. And yeah, this makes it more not that efficient. And when we are talking about efficiency to dry hopping, I would like to talk with you about the beer losses which can occur to dry hopping. And I brought a short sample explanation with me, and just numbers. And I choose to calculate in 100 hectoliters tanks for craft brewery, a huge size, but I would say for industrial brewery, average to medium size. But it makes or can show you the problem or what's happening in a practical and simple way. So we got a 100 hectoliter fermentation tank, and when you're dry hopping the 8 grams per hectoliter, and if you remember from the last slide, it's I would say the best amount for dosing for citrusy flavor. Then you will need to dose in 80 kilos in total into your tank. And because we are mostly selling our pellets in 5 kilo foils, would be 16 foils each 5 kilo. And all these dosing this amount of hops can soak up to 800 liters. And this is just 800 liters you're not able to sell. And there isn't just easy way to reduce these losses by using advanced products like our Lupomax. And we recommend, or we could say that you can replace about 50% of this dosing just by an enriched pellet like the Lupomax. And if you're cutting this, as said before, by 50%, you're only dosing 40 kilos in total, and this can absorb up to 400 liters, but probably less, because you're adding less green material, which can soak up the beer. And by this easy step, you can totally sell 400 liters more of your beer just by making a small change in your recipe. And because it's always to give my statement a little more strength, I brought you this testimonial with me from a brewery from Australia who are using Lupomax at the moment. It's like, when they said brewing with Lupomax helped us to push our dry hopping rates to harness vibrant aromas, plus it reduced the losses from the brewhouse through the package, which is always a win-win. And this is what I would say is the most it's nice words, and shows what you can achieve by just making this small change in your recipe. Okay, and to the, I would say, next problem which can occur while dry hopping is the iso-alpha acid loss. And this, I would say, don't get that much attention from my point of view, because it's, as you can see on the right graphs, you lose a lot of iso acids, and they are the main bittering compounds in the beer. And if you're losing that much iso-alpha acids to your spent material, because it's not linked to the variety, temperature, or alpha acid content, because as you can see, the low on the right side, the graph was they hopped with one times with Zeus and the other one was Hersbrucker, so one high alpha variety and with the low alpha variety, and there was no real change in how much iso alpha acids are lost to this problem. And if you don't calculate in these losses, this will change your your recipe and your flavor, or especially the bitterness output. And it's about 3 years ago when I had contact with the British brewery. We did some testing for them for a new product or a recipe development, and we just discovered that they are dosing in about, or had the initial concentration of 60 IBUs in their beers, and after dry hopping, the IBU content dropped down to 25%. So it's nearly that what it's shown on this graph. And there's an easy way to improve or solve this problem, is like using enriched pellets or extracts like Spectrum, or enriched pellets like Lupomax, because you're dosing in less green material, and this by this you will lost less iso alpha acids, and this will result in a lower change in the bittering profile. Makes your recipe more predictable and reliable for upcoming batches. Yep. Good. And on this slide, I would like to talk about some further problems which occur or while dropping, especially first of all, we would say is the hop creep phenomenon, which happens if you're dosing dry hops in the fermentation tank, and you will result in higher original gravity, fermentable sugars, then a higher CO2 concentration, and a higher alcohol content, which can be quite challenging. Next thing is what I would say is the most challenging part about dry hopping is the oxygen increase or input by dry hopping. And another thing, which especially I would say in Germany is kind of a problem, when you're dosing too much hops into your fermentation vessel, you maybe exceed the threshold or the limit for nitrates, and this is, especially in Germany, it's just 50 ppm, and if you exceeding this level by, let's say, 8 or 10 grams per hectoliter, grams per liter dry hopping, your beer is official, or it cannot be sold anymore. It's just, ruins your whole awesome product. On the other hand, which I mentioned before, is the process handling, like in the example which I showed here, about if you have 100 hectoliter fermentation vessel, you need to carry about 80, when you're dropping with the 8 gram per liter, you need to carry 80 kilos of hops through your whole brewery, and this is just quite challenging to be honest. If you're dosing or dry hopping many beers a day, then it's just a huge manpower needs to be done. On the other hand, if you want to dry hop, you need a huge capacity for a cold warehouse, because you need to store your pellets properly or proper, because if you don't do this, you will just lose a lot of aroma just because of improper storage. And again, when you're dry hopping, it's not that easy to make it repeatable, or the reproducibility. Because hops are just biological products which are under the annual fluctuations. And it would be easy to have a solution for all the problems. And as I mentioned, or maybe you could think of what I'm aiming for, is a reliable partner for the future would be, or for all your recipes, would be Lupomax, because by Lupomax you're dosing in, you got a consistent lupulin content and a consistent varietal aroma, which is specific to the, let's say, Citra or Mosaic. And just by changing it, making this small change in your recipe, reducing your beer losses, and just by this you can sell more beer. And by using enriched pellets or advanced products like the Lupomax or the Spectrum, you will have less hop creep phenomenon, because the dextrins are just based on the leaf material, and by the enrichment process for the Lupomax pellets, you will have less green material, so less potential points for second re-fermentation or the hop creep. And because they are just normally normal pellets, they dissolve, have a very nice or useful dissolving behavior, which makes them very easy to handle in the brewery, because you don't need to change your recipe or buying new equipment. And what makes Lupomax, I would say, the very nice and reliable partner for the future is the Sensory Plus technology we're applying for the production is the Sensory Plus, and I would like to show you, or to explain you what is going on. And Sensory Plus is just a pre-selection by our bathhouse experts from procurement and brewing solutions, and hereby we focus on consistency and true to type aroma in both raw hops and the final product. And further, we also keep an eye on the brewing values to minimize natural impact. And this is Sensory Plus, and this ensures your consistent true to type aroma and flavor from year to year, from year batch to batch. Just by applying this nice technique, we reduce the biological fluctuation of the hop pellets, and this makes your recipe more predictable. And on the other hand, you just reducing your losses in many cases, like the isoether acids or the total losses. And yeah, again, because talking about our all own products is kind of boring, and about a last testimonial with me, so which is, I would say, the latest one we got is from the Kamba Bavaria, from the, I would say, craft beer brewery from Bavaria, and they made a statement to us that they brewed an IPA and added almost 100% of the hops for dry hopping with their hop gun. And compared to other varieties, other hop products, it was a dream to use this hops, and they used Amarillo, Filter, and Mosaic, and they just dissolved very properly, very, very nice. All right, and this was my presentation. Thank you for your attention, and if you got any questions, I'm looking forward for the Q&A session.